Okay, good afternoon everyone. Myself Dipika Sarkar, Department of CSE AIML, Haldia Institute of Technology. And today's lecture session, I will discuss about all pair shortest path problem using Floyd-Warshall Algorithm. Okay, so first of all, the name is all pair shortest path problem. First of all, let's understand what is shortest path problem. So, shortest path problem, we can say like when we want to travel from one point to another point, that means one place to another place, we want to cover the shortest distance, right? Obviously, to get the minimum path cost, right? So this is what shortest path problem. Now, what is all pair shortest path problem? The all pair shortest path problem finds out the shortest distance between every pair of vertices of a graph. Every pair of vertices of a graph. That means what? This all pair shortest path problem can be solved using graph. So what is graph? I'm just giving you the basic idea of graph. Graph is what? A set of vertices, edges and associated weights of the edges. Okay, so this is graph. So what all pair shortest path algorithm is about? It is to find out the shortest distance between every pair of vertices of a graph. For example, suppose this is a graph. This is the graph. Okay, this particular graph contains 4 vertices or nodes. 1, 2, 3, 4. Okay, the circle ones, these are the nodes, and the arrows, okay, these are lines, these are the paths or edges of the graph. Okay, and what is this? The values 9, 6, 5, 1, minus 2, minus 4, these are all edge weights of the graph. Okay, so the all pair shortest path problem using that means the Floyd-Warshall algorithm does what? Find out the shortest distance between every pair of vertices. That means from 1 to 2, 1 to 3, 1 to 4. Again from 2 to 1, 2 to 3 and 2 to 4. Again 3 to 1, 3 to 2, 3 to 4, and if we consider 4 and then 4 to 1, 4 to 2, 4 to 3. That means we have to find out the distance between every pair of vertices. So how can we solve it? Let's understand with the help of an example. Okay, so with the help of the same algorithm, this is the algorithm. I am coming to the algorithm after we complete the procedure. Okay. Okay. So, so this is the given graph. Initially, we have to find out a distance. Distance 0. What is d0? What is this d0? Okay, 0 is, that means distance of k, using k. The value of the k is now 0. Okay, I am coming to this part. These are the formula. Okay, so later on, let's understand the procedure first of all. So d0, what do you mean by d0? When we are saying that the value of k is 0, that means what? The intermediate node is, that 0. That means what? We are not using any via path, any via node. Okay, so we have to find out the matrices out of this graph. Okay, so total 4 vertices are there, 1, 2, 3, 4, and 1, 2, 3, and 4. Okay, so we will write the distances from 1 to 1, that is 0. Okay, and 1 to 2 is what? 1 to 2, I can see 9. Okay, and 1 to 3, 1 to 3 is minus 4. 1 to 4, there is no direct path from 1 to 4. So that is why we will set it with infinity. Now next we will write 2 to 1. Okay, so 2 to 1 is 6. 2 to 1 is 6. 2 to 2 is 0. 2 to 3, there is no direct path from 2 to 3. The direction is the other way. So there is no path from 2 to 3. So which is infinity, and 2 to 4, there is a direct path which is minus 2. Okay, now next is 3 to 1. 3 to 1, there is no direct path, so infinity. 3 to 2, yes, there is a path from 3 to 2 which is 5. 3 to 3 is 0, and 3 to 4, 3 to 4, there is no direct path between 3 to 4, between 3 and 4. So infinity. Now 4 to 1, there is no path between 4 to 1, no direct path, so infinity. 4 to 2, no path, that is infinity. 4 to 3, yes, there is a path, direct path from 4 to 3, that is 1, and 4 to 4 is 0. Okay, so we have created the table for D0. Let me choose another color for better understanding. Okay, now what we will do, we will hide this first row and this first column. We will hide this first row and first column, and we will find out the distances. We will update the distances. Now what we will do, see, and this 2 to 2, 3 to 3 and 4 to 4, these are 0 only. Okay, now we will update this one 2 to 3, we will update this one 2 to 3. Okay, we will update this one in the next table. Okay, so we will write the first row and first column as it is, and we will write the diagonals as 0. Now we will find out this one 2 to 3. Now see, the distance from 2 to 3 is infinity because there was no direct path, right? Now if we consider node number 1 as the via node, then let's see what will be the result. Okay, so if we want to go from 2 to 3, how can we go? We can go from 2 to 1 plus 1 to 3. Okay, so we can go from 2 to 1 and again from 1 to 3. Okay, so what is the value of 2 to 1? That is 6. That is 6 plus 1 to 3. 1 to 3. The value of 1 to 3 is, that means the path cost of from 1 to 3 is minus 4. 6 plus minus 4, which is what? 2. Okay, 2. And earlier it was what? Infinity. So obviously 2 is minimum, then infinity, lesser than infinity. So we will update with 2 only. Okay. Now got the idea that how we are going to update it. So we will consider some via nodes. Okay. Now let's update this one 2 to 4. Okay. For 2 to 4, it will be what? It will be 2 to 1 plus 1 to 4. So what is the value of 2 to 1? The value of 2 to 1 is 6. So 2 to 1 is 6 plus 1 to 4. 1 to 4 is what? Infinity. So 6 plus infinity is infinity only. Okay. And here it is minus 2. 2 to 4, there was direct path and it was minus 2. So obviously minus 2 is minimum. We will go with this path only. Okay. So similarly, we will find out the other distances as well. Suppose for 3 to 2, 3 to 2 is 5. Direct path is 5. Direct is 5. Okay, we have find out this one also. Direct is 5. Now if we go via 3 to 1, so 3 to 1 is what? Infinity, and 1 to 2, because it was 3 to 2. It was 3 to 2. So 3 to 1, 3 to 1, that is infinity, and 1 to 2. 1 to 2, that is 9. So infinity plus 9 is infinity, and it is 5 only. Okay, so because there was direct path, right? So it is 5. Okay, we will not going to update it. Fine. Now next one, that is 3 to 4. So if we consider the via node 1, then it will be what? 3 to 1 and 1 to 4. So 3 to 1 is infinity and 1 to 4 is infinity. So and it is also infinity. So no change. So there will be no change, right? Now next one is what? 4 to 2. So for 4 to 2, we can consider 4 to 1, that is infinity, and 1 to 2, that is 9, right? So infinity plus 9 and infinity are the same, will not get update. Okay, next is what? 1. 1 is for what? 4 to 3. Okay, and if we go via node 1, then it will be what? 4 to 1 and 1 to 3. So infinity plus minus 4. Okay, so that is infinity only and it is 1. So better to keep 1. Okay, so it is what? D1 table. We got this D1 table from D0. Okay, now let me change the color of the pen. Now from D1 table we will create D2. 1, 2, 3, 4, 1, 2, 3 and 4. Okay, so to make D2 we have to do what? We have to keep column 1, sorry, column 2 and row 2 as it is. Okay, it will be intact. So 9, 0, 5 and infinity, and 6, 2, minus 2. 6 to minus 2. Okay, and we will now update it. We will now update it. Fine. So 1 to 1 was 0, 3 to 3 is also 0, and 4 to 4 is also 0. Fine. Now we have to find out 1 to 3. So 1 to 3, and what will be the via node? The via node will be node 2, because we are preparing for distance using 2. Distance using 2. Okay. So distance using 2, that means what? 1 to 3 will be 1 to 2 plus 2 to 3. So what is the value of 1 to 2? The value of 1 to 2 is 9, and 2 to 3 is 2. So 9 plus 2 is what? 11. And what was the value of 1 to 3? It was minus 4. So minus 4 is minimum only. Okay, compared to 11. So we will keep minus 4 only. Similarly, we have to find out 1 to 4. So 1 to 4 will be 1 to 4 will be 1 to 2, because we are considering node 2 as via node, and 2 to 4. So what is the value of 1 to 2? The value of 1 to 2 is 9, and 2 to 4. 2 to 4 is minus 2. So 9 plus minus 2, that is what? 7. And what it is? It was infinity. It was what? Infinity. So it was infinity. So obviously 7 is less than infinity. So we'll update it with 7. Similarly, we have to update 3 to 1. We have to update 3 to 1 using 2 as the via node, right? So for 3 to 1, it will be 3 to 2, 3 to 2, and 3 to 1. No? So for 3 to 1, it will be what? 3 to 2 and 2 to 1. So 3 to 2 is 5 and 2 to 1 is 6. Okay, so 5 plus 6 is 11. Earlier it was what? Infinity. So we will update with 11. Similarly, 3 to 4. So for 3 to 4, it will be what? 3 to 2 and 2 to 4. 2 to 4. So 5 plus minus 2. 5 plus minus 2. So that is what? 3. And earlier it was what? Infinity. So we will update with 3. Next is 4 to 1. So for 4 to 1, it will be what? 4 to 2. 4 to 2, which is infinity, and 2 to 1. So infinity plus 6, and it was infinity only. So no change. Right. And next is what? 4 to 3. 4 to 3. So for 4 to 3, it will be what? 4 to 2, that is infinity, plus 2 to 3, that is infinity plus 2. 2 to 3 is 2. So infinity plus 2, and it was what? Minus 1. So minus 1 is smaller than infinity. So we will keep. Okay. So this is how we got a table D2. Similarly, let me change the ink color for the better understanding. We have to create D3. similarly we have to create D3. Okay, so 1 2 3 4, 1 2 3 4, and this time we will keep this row 3 and column 3 intact. Okay, because we are going to use this node 3 as the via node, right? So that is why their distance will not get changed, it will be intact. Let me erase this portion. Let me erase this portion. Okay, fine. So I will write it as it is, -4 2 0 1 11 5 3. Okay, now we will update. See, this is 1 to 1 0, 2 to 2 is 0, 3 to 3 is 0, and 4 to 4 is 0. So we will update 1 to 2 via node 3. So 1 to 2 will be 1 to 3 and 3 to 2, 1 to 3 and 3 to 2. So 1 to 3 is -4 and 3 to 2 is 5. So -4 plus 5, that is what? 1. And earlier it was what? 9. So it will be 1. Okay, now next is what? 1 to 4. 1 to 4 will be what? 1 to 3 and 3 to 4. So 1 to 3 it is -4 and 3 to 4 it is 3. So -4 plus 3, that means -1, and earlier it was 7. So -1 is the smaller. So we'll update with this. Okay, next is what? 2 to 1. So 2 to 1 will be 2 to 3 and 3 to 1. 2 to 3, that is 2, and 3 to 1, that is 11. 2 plus 11, that is 13, and it was 6. So 6 is minimum only. Okay, next is what? 2 to 4. 2 to 4 will be what? 2 to 3 and 3 to 4. 2 to 3 is 2 and 3 to 4 will be 3 to 4 is 3. So 2 plus 3, that is 5, and it was -2. So it will be -2 only. Okay, next is what? 4 to 1. So 4 to 1 will be 4 to 3 and 3 to 1. 4 to 3 is what? 1, and 3 to 1 is 11. So 11 plus 1, that is 12, and earlier it was infinity. So it will get update with 12. Okay, next one is what? 4 to 2. So 4 to 2 will be what? 4 to 3, 4 to 3 plus 3 to 2. So 4 to 3 is 1, 3 to 2 is what? 5. So 5 plus 1, that is 6, and earlier it was infinity. So it will be 6. Okay, so in this way we got table for D3. Similarly, we have to find out D4. Let me change the color of the pen for better understanding. Similarly, we have to find out D4. 1, 2, 3, 4, 1, 2, 3, and 4. This time, the fourth column and the fourth row will be intact, right? And all the diagonals will be 0. 1 to 1 is 0. So 1 to 1, 1 to 2. Okay, so we have to find out 1 to 2 using node 4. Using node 4. So the via node will be 4 this time, right? So 1 to 2 will be what? 1 to 4 and 4 to 2. So 1 to 4 is -1 and 4 to 2 is 6. So -1 plus 6, that is what? 5, and it is 1 only. So it will be 1 only. Next is what? 1 to 3. So 1 to 3 will be 1 to 4 plus 4 to 3. 4 to 3. So 1 to 4 is -1 and 4 to 3 is 1. So 1 plus -1, that is 0, and it is -4. So it is minimum only, and this is intact one. Okay. Now next is what? 2 to 1. So 2 to 1 will be 2 to 4 plus 4 to 1. So 2 to 4 is -2 and 4 to 1 is 12. So -2 plus 12, that is what? 10, and it is 6 only. So 6 is minimum. Fine. And next one is the diagonal one, and and next is what, 2 to 3. So 2 to 3 will be 2 to 4 and 4 to 3. So 2 to 4 is what, 2 to 4 is minus 2 and 4 to 3 is 1. So minus 2 plus 1, that is minus 1, and it is 2. So it will get updated with minus 1 and it is the intact one. Okay. Now next is what, 3 to 1. So 3 to 1 will be 3 to 4 and 4 to 1. So 3 to 4 is 3 and 3 to 4 and 4 to 1, and 4 to 1 is 12. So 3 plus 12, that is 15, and it is 11 only. So will be 11. Okay, next is what, 3 to 2. So 3 to 2 will be what, 3 to 4 and 4 to 2. So 3 to 4 is 3 and 4 to 2 is 6. So 6 plus 3 is 9 and it is 5. So we will keep 5 only. Okay, next one is the diagonal one and the last one is the intact one, 3. Okay, and you know the last row is the intact one. So 12, 6, 1 and 0. Okay, so in this way you can see we got 4 tables for the 4 nodes. So now you can see the initial one was what, D0. That means in the initial table all the direct paths was there, right, all the direct paths, and if there is no direct path then it is infinity simply. Now from D1 you can see D1 is what, if we consider the node number 1 as the via node, then we will get these distances, that means these shortest distances between every pair of vertices. Similarly, if we use node number 2 as the via node, then we will get these distances in the table between every pair of vertices. Similarly, if we use via node 3 and if you use node number 4 as the via node. Okay, so this is the idea. So in the node 4 ultimately you will get the shortest distance between every pair of vertices, right. So this is what the Floyd-Warshall algorithm. Now let me come to the algorithm part. So here you can see Floyd-Warshall W. So W is nothing but the adjacency matrix. So n will be the number of rows out of this adjacency matrix, and D0, this is the initial one. Okay, so the initial one, D01, fine. D01, the initial one. Okay, and now see, for k equal to 1 to n, in between these three for loops are there. 3 for loops are for what? To implement this formula. To implement this formula under these 3 loops you have to put down this formula. For why? Why? Because you have to find out the distance between I and j, between the pair ij or ub, whatever, ij. Okay, ij. So for ij, one loop is for implementing I and another one is for j. And what is this k? K is nothing but, you know, the via nodes. Okay, so k will go from 1 to up to n. In this way you will get the result to d of n. Okay, and what is this d of ij k? It is what, w of ij if k is equal to 0, the simply the initial one. Otherwise what we have done, we have calculated the, you know, the distance with using the via nodes ik plus kj. Okay, and k minus 1 obviously, and if it is smaller than the already distance d of ij, then obviously update with this one. Okay, if the value of k is greater than equal to 1. So this is the idea of the whole algorithm. Now coming to the time complexity of this algorithm, as you can see in the algorithm, you know, the formula is getting implemented using these 3 for loops. So obviously it is, you know, running for n number of n into n into n, that means n cube number of times. Okay, so the time complexity will be n cube. Thank you.